bar plot can be used even for multivariate. Are you getting my point? So bar plot can be used for univariate, bar plot can be used for bivariate, bar plot can be used for multivariate. But most frequently we go by univariate, bivariate. Let's say what is univariate chart? What is univariate chart? Okay, you go to the data. You go to the data. So what you see here? Product category: fashion, beauty, electronics. I wanted to see majority of the people are buying which category product. You get my point? I wanted to see out of this number of product categories, which product category is giving me more revenue, or which product category is having highest number of customers. First, we'll see about univariate. Means how many times this fashion category is appearing in this 5,000 records. How many times the beauty is appearing in this 5,000 transactions, which indicates the number of customers buying beauty products, number of customers buying fashion products, number of customers buying electronic items. Yes or no? So from that, I can prioritize what most of the customers are willing to buy. You get my point? To know this, we go by using a bar chart. But the primary rule in bar chart, before going to do the bar chart, you need to calculate the frequency table. What is the frequency table? You know group by, pandas group by. You need to do the group by the column called product category. df dot group by product category. You need to do the aggregation called count of order ID. Yes or no? Each product category wise number of order IDs. So that is nothing but the number of orders. Now you pass that table as an input to the bar chart, then you'll get an output. Clear? We'll see that also. First, we will understand the theoretical aspects. Purpose: to compare the values across the discrete categories. I said bivariate also. I said how many times this value is appearing. Now I have a question. As per the beauty, what is the sum of price? What is the sum of final price? Okay, I'm using product category column. I'm using final price. So I'm comparing the categorical column versus numerical column. So that is known as bivariate. That is known as bivariate. We'll see. Bar plots displays a categories along the x-axis. On x-axis, you see the categories and their corresponding numerical values or corresponding frequencies on the y-axis. Each bar represents one category. Each bar represents one category. Clear? For example, a bar plot of showing the number of sales by each product category. See, I'm selling 5 different product categories: A, B, C, D, E. From this, you tell me from which category I'm able to generate more customers? B. From which category I'm getting very less? C. So what I'll do means, depending upon my time, I'll prioritize B first. If the people giving any complaints from the product category B, I'll solve those problems very quickly because high priority. Coming to C, if possible, even I stop producing the category C because waste of time. Nobody is willing to buy that. So waste of time. I'll shift the same manufacturing people into the other departments like ABC. So I can produce more products. Yes or no? So that's how you can take the decisions out of the bar plot. Clear? See, this is best used for categorical data analysis and useful for comparing the different categories. One category versus another category. Clear? So let's go to the practical implementation here. So we're done with the histogram. Bar plot. Business question is, which product category is generating most of the orders? So that I can prioritize. How? See, first of all, I said I wanted to create a frequency table. There are two ways. One by using group by or by one by using the value counts. When you go by using value counts, what happens here? Each product category wise the frequency, how many times it is appearing. So I pass this data as an input to the function. See guys, in the data frame itself or in the series itself, you have a function called plot. You can go by using the same thing by using matplotlib or C1. Anyway, you people are going to learn the same things in your regular sessions. I'll give you one more option that how can you do this. This is a series, right? It's a series, right? Category underscore category underscore count, series or not? Series. In the series, there is a function called plot. By using that also you can do the visualizations, which means by using pandas also you can do the visualization. But we regularly prefer matplotlib or C1. In the plot, you have a parameter called kind. Means what type of plot you want. I said bar chart. I said bar chart. So when I do this, I got a bar chart. You tell me from which category I'm getting more orders? Fashion. From which category I'm getting less? Home accessories. Clear? So like that you can go and prioritize. See, identify the top performing categories. Identify the top performing categories. So decision. Increase the inventory for fashion. Yes or no? Run ads on winning categories. Try to do the more advertisements for the top categories. Drop the poor performance. Stop manufacturing this home, or even stop doing advertisement because nobody is willing to buy that. You get my point? So that's how you can take the decision. See the note point. Bar charts compare the categories. Okay. So that's what. Clear? So this is how we are going to use histogram and bar chart. Remaining all we'll discuss tomorrow. Okay. I have an emergency session now itself, so I'm going out. Okay. Yeah, sorry for the inconvenience, but I'll make sure that from the next session onwards, sharp 9:10 will start. 9:40 around we'll close it. Clear? Yeah. So I hope this is clear, guys. People in online also. Yeah. Tomorrow we have a session. Okay. If there is any changes, we'll announce in the classrooms. You. Okay. I'll send those people that coordinators. You sit here only. They'll come and they'll collect your email IDs. They'll add immediately. Is this clear? Clear? For online people also. Online people also. I'll make sure that you people get access by the afternoon. Okay. By the afternoon, you people will get access to the classroom. I'll make sure that. Clear? Yeah. Okay, guys. Then thank you. Home accessories. Clear? So like B, C, D, E. From this, you tell me from which category frequencies on the y-axis. started working on the visualizations. Good, good. So okay guys, as you people know, we started working on the visualizations. Okay, so yesterday we have discussed about how to join in a classroom, sir. 1 second guys. Yeah guys, online people, most probably you people will receive an email by giving an accept request. So just accept it and you'll be get added to that particular classroom. Okay, most of the offline people are already added to that. I'll make sure online people will be getting the access by the afternoon itself. Clear? Yeah, good. So guys, as you people know, we are in the phase of descriptive statistics. So we know the descriptive statistics can be identified in 3 different ways. One is measures of dispersion, one is measures of central tendency, and even by the data visualizations. Yesterday, we have gone through the visualization called histogram, how it is going to help you to take a decisions. Okay, yesterday we have gone through the what you call e-commerce data, how the customers are spending high value or low value order items. Okay, and also we have gone through the bar chart. How the bar chart is going to help you to identify which category is giving you the more sales or which category is giving you the more amount kind of things. Okay, so that also we have discussed yesterday. So now we are going to discuss about the pie chart. See guys, bar chart and pie chart both works for the same purpose. Okay, bar chart is also used to compare the categorical data across the frequencies. Same way, the pie chart is also used for the same purpose to compare the different categories across the numerical value, means frequencies. So then why should we use pie chart? We already have a bar chart. Okay, whenever you see the bar chart will give you the frequencies as an individual bar. But when it comes to the pie chart is a statical graphical chart which will be represented as a circle, which is used to show in terms of proportions. Means out of 100% sales, for example, I got a revenue around 20,000 from different categories, product categories like electronic items, fashion wear items. I wanted to see out of this 100% sale amount, how much is the contribution of one particular thing. When it comes to the bar chart, it will just give you the number. What is that number? But out of 100%, is it 50% contributing or is it 20% contributing? This is not visible in bar chart. So if you wanted to visualize the percentage of contribution among the 100%, then you can go by using pie chart. Is this clear? So pie chart is specifically used for univariate or bivariate analysis. Clear? See, when you people are going to do this exploratory data analysis in your real time, again you people go through this particular thing. There you might do by using Matplotlib and Seaborn and SciPy, but here we are going to do by using pandas. Is this clear? Might do by when you people are going to do this exploratory data analysis in your real time, again you people go through this particular thing. There you might do by using Matplotlib and Seaborn and SciPy, but here we are going to do by using pandas. Is this clear? Okay. See, pie chart. This is used to represent a parts of old data. See the description. Pie chart displays the data as a slices of a pie. Here, each slice will increase or decrease depending upon the proportion. If there is a particular category which is contributing more, then we'll have a bigger slice. Okay, less means less slice. That's what. Example, look at the pie chart showing the percentage of distribution of sales across the different regions. So let me zoom out this particular bit. Please look at the chart, guys. Whenever you see this, see A, E, something else you have. In this, you tell me from which region we are able to generate a more revenue, or which region is contributing more. See B. Which category is contributing very, very less? That is C. So depending upon that, you can prioritize the advertisement. You can prioritize your works. You clear? So this is how we are going to use pie chart. But this pie chart is not always usable and not always suggestible. Why? See, as you people know, as the contribution is increasing, slice increase. As the contribution decreases, slice decrease. As the number of categories are increasing, more slices will get it. More, for example, you bought a short size pizza. Okay, minimum size pizza. 2 or 3 friends wanted to share the pizza. Okay. If 10 people coming to share that pizza, each person will get a small piece. Yes or no? Will it be sufficient? No, same way. If you are cutting the slice, so many slices, it is not possible to get any insights. It's not possible to understand anything out of this because every slice looks same. It is 2 or 3 friends wanted to share the pizza. Okay. If 10 people coming to share that pizza, each person will get a small piece. Yes or no? Will it be sufficient? No, same way. If you are cutting the slice, so many slices, it is not possible to get any insights. It's not possible to understand anything out of this because every slice looks same. So what is the purpose of doing this particular chart? Please remember, whenever you wanted to compare the categorical values, if you have more categories, let's say more than 7, more than 6, then go by using bar chart. If it is less than 5 or less than or equals to 5, then go by using pie chart. Pie chart looks very good when you have a less categories. Is this clear? Or less than or equals to 5, then go by using pie chart. Pie chart looks very good. Compare the categorical values. If you have more categories, let's say more than 7, more than 6, then go by using bar chart. If it is less than 5 or less than or equals to 5, then go by using pie chart. Pie chart looks very good when you have a less categories. Is this clear? Keep this in your mind. Okay. So depending upon that, you can decide. Sir, whenever we are working in a real team, do I need to decide the chart? No. There will be two scenarios. First, the client will come with a requirement. See, I wanted to visualize so and so. So and so. If you are reporting like Power BI and Tableau, they will decide what type of chart they want. For example, you're doing for your own analysis. You're doing by your own analysis to give a appropriate insights. At that time, you can go by use n number of charts. No restriction. Clear? Clear? When it is a real time, you can ask the people, is there any requirement? If they are saying no, you can go by your own decision. First, you need to ask and you need to confirm. Clear? So that's what. Let's see the example that we have in the notebook yesterday. See guys, as you people know, yesterday, I have created one dummy data like order. Rate, customer age, gender, city, product category, and all those things. So in this, I wanted to analyze the product category. Yesterday, we already did it by using a bar chart. Same thing I'm going to do by using pie chart. By using pie chart, what is the business question that I wanted to address? One second. One second, guys. Yeah, sorry. So guys, you see you already created yesterday the data. Now from the data, in that I have a column called product category. I have a column called product category and some city. Like this, I have a categorical columns. Now I wanted to address the business question, that is, which city is contributing most of the sales. I wanted to identify the city where I can get the more amount, more sales or more revenue amount. How can I identify? I'll go by draw the pie chart by using the city column so that I can identify. Okay, see how I'm going to do that? Simple. If you wanted to do the bar chart or pie chart, first you need to create a frequency table. How you get a frequency table? In two ways. One by using value counts, or another one by using group by operations. Yesterday we have already seen value counts, so now we'll see about group by. Okay, so what I'm doing is I'm grouping the data based on the city column. Based on the city column, which means I'll segregate the records where each city is something. Okay, then for each group of city records, I'm going to sum the final price. Final price means final bill amount the customer is paying. So by each city wise, what is the sum of final bill amount that I wanted to calculate? See, when I do this, so when I do this, see what is my output? My output is like this. From the Bangalore, this is the amount. From Chennai, this is the amount. From the Delhi, this is the amount. Hyderabad and Mumbai. Like this I have. Now I'll represent exactly this series as a pie chart. How? You see. In Pandas series, there is a function called plot. Yesterday also I showed you. See, I don't want to go by the Matplotlib and Seaborn because people will already learning in that. I'll give you another way. Okay. So in the Pandas series, you have a function called plot. The plot function will take the multiple parameters as an input. One of the primary parameter is that what type of chart that you wanted to draw. Kind means what type is equals to pi. Pi means the program will automatically identify you wanted to draw the pie chart. After that, you see automatic percentage is equals to 1.1, which means you see on the pie chart, you're getting the contributed numbers, right? Contribution numbers, that numbers representation you wanted to decide. Formatting, number formatting. What I'm saying, show me the number with only one decimal point after the dot. Here 1.1 means show me only one decimal after the dot. What is this? F means floating point. After F, you see the percentage. See 19.4. After that, you get a percentage symbol. So that's what I'm formatting. I hope you people will learn or already learning the string formattings, string formatting, F formatting, F string, percentile formatting. Okay. Some people have already learned, some people are going to learn, I guess. Okay. Yeah. So now I'm doing this. Let me run this. Not learning. You people will learn for sure. Okay. Sorry guys, I reopened this one, so I have to import the library. But I'm getting the error. Import matplotlib.pyplot as plt. Why I'm using this means, yeah, chart I'm doing by using pandas data frame, but the customization of the chart is I'm doing by using matplotlib. Okay. Now you tell me guys, from which city we are getting most of the revenue? See, Hyderabad. Hyderabad 20.7. Yes. The next priority is Bangalore. Next priority is Delhi. Which means, for example, I wanted to open a new outlet of my business. So which location is my high priority? Hyderabad. What is my next priority? Bangalore. Like that, I can prioritize. You get my point? Like that, I can prioritize. And I'll do more marketing in the Bangalore and Hyderabad because there I'm going to generate more revenue. If I'm able to reach out to the most of the people, then I can increase revenue. That is the way the business people are going to take a strategy. You clear? That's what. See the insights. Show the revenue share. The decision that you're going to take out of is expand the warehouse into the top cities. Just now I mentioned. Expand your business or open multiple branches. Clear? Next, optimize the logistics. Optimize the logistics. See, note that use pie chart only for the proportions, not for the comparisons. Okay. If you wanted to see the contribution of one among the others, in that case, you can go by using pie chart. If you wanted to compare multiple categories, one after the other, go by using bar chart. Clear? Okay. See, guys, I'm always saying if you wanted to compare multiple categories, one after the other, go by using bar chart. Clear? Okay. See, guys, I'm always saying that whenever you're learning, you need to learn when to use. How to use, you can get it from even ChatGPT also. Okay, that's one. So next chart that we are going to discuss is box plot. Box plot. See, most of the people already know about the box plot. See, the purpose of the box plot is specifically to visualize the distribution of the numerical column. Here also, box plot can be used for univariate analysis and also can be used for bivariate analysis. When it comes to the univariate analysis, this can be used to analyze only a single numerical column. When it comes to the bivariate analysis, this is used to compare the relationship between one categorical variable, one numerical variable. One categorical variable, one numerical variable. I'll explain you what is that. Okay. First we'll see. Box plot displays 5 important statistics. What are those? Minimum, first quartile, Q2, second quartile, Q3, third quartile, and the maximum of the given column. Yes or no? See, they are also used to show the outliers. See, to check the distribution of a numerical column, we already have a histogram. We already have a kernel density estimator. This box plot specifically dedicatedly used to only identify the outliers. Everybody, data analysts or the data scientists, everybody use a box plot only to identify the outliers. That's all. Okay, you people also make that particular thing clear. Okay. Yeah. See, key points. This is useful to identify the outliers and even understanding the spread of the data. Also, use it to compare the distribution between multiple categories or multiple data sets. See, this is how it looks like. You see, guys, this is the box plot. In this, the lower line you see, this is nothing but a minimum sale amount. Let's assume this is a sale amount. This is age, right? Let's say age. What is the minimum age of your customer? 20 years. You're able to see 20 years. See, 1 second. Yeah, is it visible now? Somehow? No? Now? Now? Is it okay? Yeah. See, drawing the chart is very easy. Getting a story out of is the problem. That's why I wanted to make sure you people are able to see properly. Okay. You see this. In this is the minimum point. The upper line is the maximum point. Okay. So the middle line you see, center line, middle line means median. Median is nothing but a Q2. In this box, you see the box starting. This is nothing but Q1. The box ending is nothing but Q3. So from this, now you people tell me, what is the minimum age of my customers? 21 around. 21, 20 above it you have. 21, 22. What is the maximum age of my customers? Around 59, 58. You got 2 insights. So your customer range is from 22 years to 55 years. So you target only those people. You target only those people. And coming to the middle age, on an average, what is the most frequent customer age group? 40. What is the most frequent age group? 40. Are you able to see how you are getting? So this is how you need to identify. Clear? So when it comparing to the multiple categories, let's say when it is about multiple categories, when you have a multiple categories, same chart you get in multiple ways. I'll show you. Okay. For example, this is the chart that you wanted to write. For example, you're comparing the multiple categories. So you will get a multiple boxes. For example, you're comparing about the south region. You're comparing about the south region. Okay. This is the total sale amount from the south. Same way, you have drawn one more chart, one more box plot. This is from the north region. This is from the north region. Same way, you'll get one more box for another category. Let's say this is another category. This is from, let's say, west region. Okay, and another one you have, this is from west region, sorry, east. Okay, so why we need this particular thing? Now you tell me, among which particular region the average sale amount is more? On an average, from which particular region I'm able to generate more revenue? East region, because you can easily see the comparison. You tell me from which region the average revenue is very, very less? West. West, guys, the blue color line. South, see, south green color here, blue color below bit. See, compare this line, guys, the central line. Okay, I'll do one thing. Let's say this is the central line. Now west is the lowest region. So you can decide where to concentrate on the more sales, where to concentrate less on the sales. So like this, you can compare. Like this, you can compare. You get my point? So this is how you're going to use the box plot even for the multiple categories. Okay. So let's go to our practical example here. I just wanted to see, are there extreme spenders? Regularly, the people are spending. I wanted to identify, is there any customer who is spending extremely high, like outlier? than my expectation. I wanted to do that. We know the box plot is flexible to identify those. So let's go and do it. How? See, I wanted to draw the box plot. In the matplotlib, you have imported matplotlib.pyplot as PLT. In that, to draw the box plot, you have a function called box plot. See guys, you just remember the chart name, that's all. Box plot, box plot. You wanted to draw one more chart, the name is also same like that. Pie chart, pie chart. If you wanted to draw the scatter plot, the function name is scatter. Okay, so from the PLT library, I wanted to get the box plot function. For that function, I'm giving a numerical column as an input. I'm doing this. See, when I do this, this is the output I have received. You tell me what is the average order value of the customers? 7,600, 7,500 around. Now you tell me, do we have any outliers? Do we have any outliers? No. The box plot is, for example, you have any outliers. If you have any outliers, then you get some dots out of this particular upper limit and out of this particular lower limit, the minimum value, maximum value. If you have any dots, then that is treated as an outlier presence. If you don't get, means you don't have any outliers. Is this clear? Is this clear? See, if possible in upcoming sessions, I will show you the data which is having outliers. Clear? So that's what. See, detect the outliers instantly. See the median and also the spread. Decision. By looking at the box plot, you can create a VIP program if you see any outlier or if you see any extremely. What is the box which is colored? Means? Sorry. I'm not able to understand what you're asking, man. What is the box which is colored? Q1 to Q3. Yes. This is quarter one. This is quarter two. Sorry, this is quarter two. This is quarter three. Which means see Q1. Q1 means how much? 25%. If you are calculating 25% means what do you mean to that? Top 85. Sorry, 25% means top 75% of the people are spending from 2,600 to 7,500. Getting my point. See what is this Q1 says? Q1 stands for what? Let's say around 2,700 or 4,000. So Q1 says that 25%. 25% means top 85% of the people are spending the amount around 4,000 rupees. You see this Q3. You see this Q3. Q3 means how much? 75 percentage. 75 percentile value means top 25% of the people are spending around 12,500. 12,500. Like that you can communicate. Okay. These are the insights you can get out of the box plot. Clear? No. So same way you can plan for the VIP programs if you see any outliers. Okay. So this is how you're going to use the box plot. Next, scatter plot. This is very, 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 very important. Being a data analyst, being a data scientist, without the scatter plot, you do nothing. Okay. See, in data scientist, one of the important step in a machine learning project or a data science project is you need to eliminate the unwanted columns called dimensionality reduction. Dimension means columns. How do you eliminate the columns? Let me give you the example. For example, I wanted to analyze the earning capacity of the Indian men. Okay, people in India. I wanted to analyze how is their earning capacity. So to do this, what I'll do, I'll collect the data. What I collected: name of a customer or a name of a candidate, father name, age, location, gender. You get my point? Gender, educational qualification, everything I have done. You get my point? Everything I have collected. You tell me, is name of a candidate have anything to do with the salary? Let's say my name is Kotishwar, so I'll become a Kotishwara. In general, I'm saying, if I name myself as a rich man, I'll become a rich man. Is the name have anything to do with the income? No. So it is unnecessary. See, I told you the machine learning algorithm is like a kid. Whatever you show to whatever you do in front of a kid, same will be replicated by him. So you need to eliminate the unwanted data. You need to give a neat and clean data, then only you'll get a good output. So to do so, we'll eliminate the unwanted columns. How do you know unwanted column? See, now I'm just guessing, even though I don't have an evidence. There might be a chance. See, that's why only people will give the names, right? They'll go to the Brahman people, they'll ask the time and all, then only they'll decide the name. Yes or no? You don't know, I don't know. But being a data analyst, being a data scientist, will talk in terms of proof. So how do you get a proof? By using scatter plot. Scatter plot is specifically used to find the relationship between two numerical variables. Only numerical variables, the two. Univariate, it's not suitable. Multivariate, it's not suitable. Only for bivariate. For example, I wanted to do the marketing spend. You getting my point? I wanted to spend some amount on marketing. I wanted to find, is my marketing spend and my sales have any relationship or not? You getting my point? I wanted to identify, is my marketing spend, the amount I'm spending on the advertisement, and the amount I'm getting as a revenue sale, is there any relationship or not? I wanted to identify. Okay, to do that, I'll go by writing a scatter plot. Okay, scatter plot is like a coordinated plot, guys. So how it looks like means, so whenever you draw the scatter plot, this looks like this. Okay, in general, I'll give you one small example. Whenever you people are going to write a scatter plot, the primary thing that you need to identify, what is the independent variable, what is the dependent variable. Usually, independent variables will be denoted by X, dependent variable will be denoted by capital Y, in general Y. Yes or no? Let me give you the basic example, height and weight. Height and weight of a particular person. I just wanted to find, is there any relationship between the height and weight? Now you tell me, height and weight, which one is dependent and which one is independent? Let's say, if weight increases, height increases, huh? No. Let's say, if height increases, weight increases somewhere. Weight increases, height increases, no. But height increase, height, if bone height is increasing, automatically weight increases. So here, height is independent, weight is dependent. You get my point? Height is independent, weight is dependent. So let me draw the height on the x-axis and the weight on the y-axis. On the y-axis. So for example, the weight is something, the height is something. Okay, the height is something, the weight is something. The height is something and weight is something. Like that, whenever you do, let's say the corresponding dot you get like this. Scatter plot is nothing but you get a scatter plot like this. Whenever you get a dots like this, from this chart, you can identify so many things. One thing, if the dots are very close to each other, yes, each and every data point is correlated. Another thing, whenever you draw like this, if you join all the dots, if you are able to see the shape like this, means as the x increasing, y is also increasing. Yes or no? If x increasing, y is also increasing. Means x and y both are moving in the same direction, which means x and y are having a positive correlation. You get my point? Having a positive correlation, which means if one is increasing, another one will also increase. If one is decreasing, another one will also decrease. This is you can identify by using a scatter plot. You get my point? For example, whenever you draw the same thing, when the weight is something, sorry, the height is something, the weight is like this. As the weight increases, sorry, as the height increases, weight decreasing. As the height increases, weight decreasing. Whenever you see the shape is looking like this, downfall. Then in that case, what you have to say, see, as x increasing, my y is decreasing. Yes or no? In this case, what you say is, yes, both are correlated only. Means there is a relationship. But what type of relationship? Negative. Negative means if height increases, weight decreases. If height decreases, weight increases. Both are moving in the opposite direction. One going up, one going down. This you can identify by using a scatter plot. Sir, how can we say there is no relationship? See, height increases, weight same. Height increasing, weight same. Height increased more, even though weight is same. When you see the shape looks like this. When the shape looks like this, then you can say that they are not at all correlated. So simply you can eliminate the height from your analysis because it is not at all contributing our target variable. So why should I waste my time in having that in the data? You clear the purpose of scatter plot? Specifically use it to find the relationship between two numerical columns. and it will give you the direction of relationship, whether positive, negative, or zero. No direction. Clear? So that's what. Let me go back to this thing. See, I already explained all the technicalities. Let me read the theoretical part. Scatter plot. Use it to explore the relationship between the two continuous variables. See the description. The scatter plot displays individual data points on a two-dimensional plane, means x-axis and y-axis, where each point, where each data point represents a pair of value. So no, here, what is this value? X is something, Y is something. X comma Y, X2 comma Y2, X3 comma Y3. That's what. Okay, that is how you are going to get this value. Is this clear? Is this clear? So this is how you are going to use a scatter plot. See, example, a scatter plot showing the relationship between number of hours he is studying and the score he is getting from the exam. We already know, guys, if you are studying more, you get a best score. If your number of hours you are studying is increasing, automatically the percentage in the exam will increase. So to check that, I have written this particular thing. Okay, just assume. Okay, just assume this is the chart. Okay, number of hours increasing and the percentage is increasing. Okay, like that you can identify. See, as a reference, I use this chart, but when you see the original one, as it increasing, the dots will go up. Okay, so that's what. See the key points. See the key points. Great for detecting the correlation or the trend between two variables. And also sometimes it will help you to identify even outliers. How? You see here, everybody is a small range of height. there is one particular person with a large height, like this, like this. See, in regular classes also, all the people are sitting on one particular side. One student came suddenly sitting over there. What do people think? He's something different, abnormal. He's behaving different. Yes or no? Everybody is in this group. This fellow standing separately alone. He's an outlier. So this is the way also you can understand outlier presence. Clear? But we go by box plot only. But I just wanted to know what if it is increasing sometimes and sometimes decreases, how they are related to each other. In that time you can say yes, they are related, but the relationship is not stable. So you cannot decide if it is one increasing, another will definitely increase. You cannot go by taking a decision. See, if I do marketing spend, 1,000 increasing, 2,000 decreasing, 3,000 increasing. In that case, I'll never take a decision that if I do more marketing, I'll get more. Instead of, I'll do the stable marketing. Only 2,000 rupees every month. Either way, I'm not getting much stable. So that's what. Depending upon the scenario, you have to change the decision. That's all. Clear? That's what. See, this is the specialty of a human being. You people might have heard about AI will replace the people. No, AI cannot do this kind of things. Human can do. Okay, that's what. AI is just used to do the work fast. That's all, not automatically. Okay, so next we are going to see about the density plot. Next we are going to see about the density plot, kernel density estimator plot. Okay, so which looks like this. It's like a smoothed version of histogram. It's like a smoothed version of histogram. In histogram, each bar you can see the bar lines. Here it's a smooth one. Getting my point? See, same. This is also used to see the distribution of a numerical variable. See, the density plot is a smoothed version of histogram. It shows the probability density function of continuous variable. Clear? Same guys, whatever we have discussed over in the histogram, same will be applicable in the density plot. You clear? So see, this provides a smoother visualization of the distribution of compared histogram, comparing to the histogram. See guys, whenever you go here, you can simply write one particular line on top of this. Yes or no? You can simply write one particular line on top of this. How? Let me show you. I can draw a connectivity line between the top edges of this particular thing. Now you tell me, the data is normally distributed or not? The data is normally distributed or not? So this is the way you are going to use a kernel density estimator to check whether the data is normally distributed or not. See guys, not everybody 100% perfect. Somehow is perfect, then we'll say perfect. In the data science, in the data analytics, we have a central limit theorem. What is the central limit theorem is saying that if you keep on practicing, if you keep on collecting the data will become obviously a normal distribution. Initially it is not. Increase the sample size, slowly the data will be converted into normal distribution. So we believe that which is approximately normally distributed. Okay, you can never find exactly normally distributed data. Clear? Everybody is not 100% perfect. Same. So this is how you are going to do this. Clear? See, already we have discussed enough about the histogram that I wanted to close this by. Next, heat map. Next, we have a heat map. See, we know guys, which is keep on 100% perfect, the edges of histogram. See guys, whenever you go here, you can simply distribution of compared histogram, comparing to the histogram. You can simply write one particular line on the data is normally distributed, 100% perfect. Somehow is perfect, then we'll say perfect. In the data, that if you keep on practicing, increase the sample size, slowly the data. Okay, you can never are going to do this. Heat map. Next, we have a heat map. See, we know guys, specifically heat map is used to visualize the table structure. Heat map is specifically used to visualize the matrix or the table. In data science or data analytics, we calculate the correlation. We find the correlation. Okay, I think you people have seen this. In pandas, there is a function called data frame dot CORR. Okay, if you apply that, you'll get a correlation matrix. Okay, if you pass that matrix as an input to the visualization, it will give you the chart like this. It will give you the chart like this. It will represent the relationship between the multiple numerical variables at one go. See, by using scatter plot, you are able to find the relationship between two numerical variables. If you want to do more, scatter plot is not suitable. So what you have to do, multiple scatter plots, waste of time. So instead of that, you can go by finding the correlation matrix. Whenever you apply the correlation, I'll show you again, we have a discussion of that. When you apply the correlation function on top of it, automatically it will collect all the numerical columns from your entire data frame. By default, it will work with only numerical columns. It will take all the numerical columns and it will create a bivariate scatter plot for each and everything. Depending upon that, it will give you the relationship strength in terms of color, in terms of number. Whenever you do the histogram, if you are getting a darker color between two categories or two variables, means those two are strongly related. Strongly related. If you see the light color in the heat map, which indicates that two numerical variables are having very low relationship. Clear? When it comes to the number, the numbers will be displayed from 0 to 1. 0 to 1, let's say 0.5 means, for example, here say 0.5, G and G3. Here, G and G3 are correlated. How much is that correlation? 50%. 50%. Here, let's say, see here, C and G1 is having 0.9, means 90% correlation. Sir, what is this 90% correlation we're saying? Let's say, I'm doing an analysis that marketing spend and the sales I'm getting. Okay, I got to know that marketing spend and the sale amount I'm getting is having 80% correlation. In that case, what I mean to say that if I increase 1 unit in the marketing spend, let's say I increase 100 rupees in the marketing spend, then in the sale, I'm going to increase 80 rupees. You get my point? If I increasing 1 unit in independent variable, which is going to show the effect of 80% on the dependent variable. You get my point? For example, number of hours I'm studying and the exam score I'm getting. If my score, I'm studying 2 hours, my score is 55%. Then I got to know the relationship as a 5%. Okay, 5% or 0.2%, which means if I study 1 more hour extra, then I'll get 5% extra score in my exam. 55 to it will become 60. Like that, you can communicate the insights. Okay, we'll discuss better about this when we are going to discuss about the correlation and regression. Okay, just now it's like an oral view, how the heat map will be working and how it will be represented. See, the heat map, the purpose is to visualize the magnitude of the values across the 2 dimensions. See, description, heat map displays the matrix format where the individual values are represented by the color gradients. Same box, whatever the metrics you got, that will be visualized with the colors and grids. Grid means boxes. So that is the speciality of heat map. That is the speciality of heat map. Okay. I hope I have added the example for this as well. Let me go to this. Scatter plot. Anyway, okay. See, even the density plot, guys. I just wanted to see the final price distribution. Final price distribution. See, almost all it is normally distributed, approximately normally distributed, means the final price is very good. Not much low, not much high. And when it comes to the heat map, see, as I said, we have a function called correlation, CORR. So what I'm doing in my data frame, I'm identifying what are the numerical columns I have. Okay, you tell me what are the numerical columns I have in my data. Order ID is not the numerical column. It's a unique identification. You don't involve in the analysis. Next, customer age, price, discount, rating, final price, delivery delays. So what I'm doing here is I'm subsetting, means I'm creating a data frame with only few columns: price, discount, rating, delivery date, and final price. On top of it, I'm applying the function called CORR. It is a short form of correlation. Whatever the metrics I'm going to get, I'll save that into this particular variable called CORR. Let me print this. See, whatever the metrics table you are getting, you are going to visualize the same table as a grids with a different colors. That is nothing but a heat map. Okay, so now you tell me. See, guys, the correlation map or the heat map is available in the library called Seaborn. It is not available in Matplotlib. It is not available directly on the pandas. If you wanted to draw the heat map, you must get it from the Seaborn. How? See, just now I imported Seaborn as SNS. It's a famous alias name. Next, in Seaborn, there is a function called heat map, which will be helpful for you to draw the heat map. So correlation is the input, and I wanted to see. See, same box I visualize. See, 1, 1. See, 0.011, 0.011. See, minus 0.07, 0.07. Just a graphical representation. That's all. Now you tell me, what are the two variables are having highest relationship? Positive or negative? What? Observe the discount. Observe the discount. 0.22 means 22%. That too negative. That too negative. You see, final price and discount. Final price and discount are having highest negative correlation. That is minus 22%, which means if you keep on increasing the discount, the final price will be get decreased. Yes or no? Item price is 1000 rupees. 50% discount. How much? 500. 75% discount. 250 rupees. As the discount increasing, the final price is decreasing. Yes or no? So that we can see. That we can see. It is a strong negative correlation. So you get a dark black color. Okay. So this is how you can do this. Okay. See, when you people are going to work with the visualizations, there you people might learn the formatting of this. You can select the colors of your requirement. Red, blue, green, yellow. These are by default. You can do the customization. I hope you people will learn your regular sessions. Clear? So this is about the descriptive statistics. Clear? This is about the descriptive statistics. So in the next session, we are going to see about the probability and the probability basics. Okay. Sir, how these values are calculated? Don't worry. How these are calculated? What is the formula behind? How did I got this 0.011? We'll discuss at the time of correlation. If I explain here also, again, I need to waste time over there. Okay. At that time, I'll clearly explain you the backend formula. Then I'll explain it. Okay. So everybody's clear. So people in online, heat map is not clear. So what you're not able to understand, tell me, Mr. Shivam. What about you guys? Anyone have any questions? Anyone have any questions? Sir, this is my first session. Is there any classroom for notes? Yes, yes. Shivanal, whatever it is. Okay. I'm sorry. Yeah, you'll get a classroom link. I'll make sure the people will share you the classroom link through the email ID, like how you people received the regular classroom. So I already added the classroom notes. And even the guys, they are already posting day 1, day 2 recordings in the classroom itself. The links you can watch over there. Whoever missed the previous sessions. Is this clear? That's one. Can you revise the heat map again? Okay, I'll revise on the Monday, guys. I'm rushing for the next session. Okay, I have to start at 10 o'clock, but it's already 10:08. Is this clear? I'll revise on the Monday. First, I'll revise that in a few minutes, and we'll continue from the probability and its basics. Clear? Okay, guys. Thank you. Happy Sunday. Okay, then we'll continue from the probability. Don't have any questions here? This is I'll take this. Yes, sir. Uh, Map different. I'm going to what analysis next class. When it comes to the heat map, see, I just wanted to see the heat map. Okay.
Okay, so let's start the session, guys. I'm really excited to start the another DSA Python batch today. Okay, so this batch is going to start on this day, which means on 4th Feb 2026. Okay, so and you can join here through offline mode and online mode, both modes also you can join here. Okay, so then okay, so let's start with a real world problem. And now okay, so I think my voice is now how's it, guys? How's my voice? Is it clear or not? Yeah. Okay. So I'm gonna share my screen too. So just let me inform. Okay. Okay. So a lot of people are trying to learn the DSA, and most of the people are watching a lot of YouTube videos as well, right? So while in your degree or in your graduation, I saw personally that a lot of people are trying to learn DSA from various YouTube channels and from few websites, right? But then while watching, they remember the concept or whatever the topic is, but the next step, again blank. Okay, so then if you see whatever the topic is, but then while watching, they remember the concept or whatever it's right. People are trying to learn DSA from various YouTube channels and from few websites, right? But then while watching, they remember the concept or whatever the topic is, but the next step, again blank. Okay, so then if you see a particular problem on the LeetCode or somewhere else like a HackerRank or CodeChef, okay, so I know this problem. I know this problem is belongs to two pointers concept, but when in real time, when you are in interview, so at the time also your brain is going to be blank. So see, there are some situations that where we get confused and even though we know the concept or the approach, the answer, but still though due to nervousness we can't able to answer, right? Yeah, so that's also one of the core reason that nowadays the interview is short. Why? Because okay, and I'll tell you one more thing also that I don't usually share on day one, but I also come through the same situation. So when I want to learn DSA, I also same like so I browsed a lot of websites to pursue DSA course, and also a lot of YouTube channels also I saw. And the sad thing is you rarely see DSA with Python course, right? So everybody in the YouTube also they trying to teach English with C language, C++, and most of the people are spread over all the world that DSA with C++, DSA with C, or DSA with Java only are the acceptable. DSA with Python is no more acceptable. I don't know who spread this illusion, but that's actually biggest myth, right? So imagine you are a Formula One driver. You have to become the first, right? So you have to focus on how to overtake the next person to you or something, how to ride, right? Instead, so you are pedaling the race button, but the pedal is not working. Then you are changing the gear, and the gear is not working. Why you have
And this is very sorry guys for the online people actually. Say we are not able to add you to that particular classroom. Don't worry. Say before closing this particular session, I'll be displaying the QR code. Okay. So if you scan that, you'll be able to join in that particular thing. Okay. Yeah, sure. Good. So guys, as you people know that in the previous sessions, we have completed about the descriptive statistics. Okay, we can find the descriptive about the business in multiple ways, like by using measures of central tendency, measures of dispersion, and even by the data visualization. So we have covered most of the important charts called histogram, pie chart, bar chart, box plot, scatter plot, and heat map. Okay, so you might see so many visualizations like donut chart, even waterfall chart. So many you have, but in regular day-to-day life we use only this. Okay, so that is enough. So in today's session, we are going to start learning about the probability and its basics. Okay, so today we'll cover the basic definitions and all the things, and tomorrow we'll extend this particular topic. Is this clear? So before going to dive into this particular thing, does anyone know about the probability? Sorry, anyone ever used or anyone ever heard about this particular thing? Yes. See, I'm already said this thing so many times. You people are already started using statistics and probability in your life, but you don't know that is called so and so. That's all. I gave you the simple example on the day one itself. For example, you and your friend are staying in a particular hostel. Okay, you get a summer holidays, you get some Sankranti holidays or something else. You're moving to your hometown, and immediately the right question asked by your friend is that when you'll come back. When you will come back. So what you'll say in general English? Most probably I'll come by the next Sunday or next Monday. So most probably means there is a high chance I might return by the Monday, and there is a very less chance that I may not come. Yes or no? For example, you are going to a particular exam. Immediately coming home, your father is asking how much percentage you are expecting. Most probably I'll get around 85%. Most probably I'll get a first distinction. If something goes wrong, I might get a second division. Yes or no? So this is nothing but the probability. You're using a theoretical statement. So today we are going to see the practical implementation. How can you get evidence? Not just a random statement, a proof of statement. Clear? So that's what. See, probability is also a branch of mathematics and statistics. See guys, basically, we all know statistics is a branch of mathematics and statistics. But in general, in back in days, it's a branch of arts and commerce. At the time of Akbar, Birbal, those people introduced this particular statistics to know the vital statistics. Vital statistics means number of people taking birth in their empire, number of people are died, male candidate, female candidate. Slowly, the features of the statistics evaluated. So all the fields are using this particular statistics. Now we say probability and statistics is a branch of mathematics and science. Okay, so probability is also a branch of mathematics that deals with calculating the likelihood of an event. Likelihood means the favorable chances. The chance of happening is nothing but a likelihood. Okay, so by using probability, we measure this likelihood of an event occurring. Don't worry, we'll discuss about what is event as well. So in data science, probability theory is used to model the uncertainty. Uncertainty means you are not sure what is going to happen. You are not sure what is going to happen. You are not sure what is not going to happen. If you wanted to measure this uncertainty, then we go by using probability. You can say two definitions. Probability used to find the likelihood of happening an event, or it is used to measure the uncertainty of the event. Clear? So that's what. This is used to predict the outcomes and even understand the randomness in data. Understanding the probability is very, very important being a data scientist. In data science, you will be going to work with the machine learning projects. Machine learning projects are basically divided into two types: regression problems, classification problem. Coming to the classification problem, whenever your target is a categorical column, that too bivariate, means it will take only two outputs. You get my point? Your target variable saves only two values as an input. In that case, we go by using classification algorithms. In the classification, most frequently used algorithm is Naive-Bayes. Okay, in that it purely works with a Bayes theorem. If you understand the Bayes theorem, you need to understand the probability basics. You get my point? So that's what. See, what is the probability theory saying? See, the probability theory is a mathematical framework used to describe and quantify the uncertainty. It assigns a probability to each possible outcome of a random event. First of all, what is random event? First of all, what is event? And what is random experiment? First of all, what is experiment? Experiment is something which will give you the output. Yes or no? Experiment is something which will give you the output. Then what about random experiment? Whenever you do the experiment, you know the outcome in prior. You get my point? Yes or no? See, whenever you do the experiment, you know the output in prior. That is called experiment. What about random experiment? Whenever you're conducting an experiment, you're not sure what is the output. You're not expected what is going to become as the output. That is known as a random experiment. Regularly, we use the basic example of tossing a coin. For example, I'm tossing a coin. Can anyone guess that is it going to get a head or tail? No, you are not sure what output that you're going to get. This is nothing but a random experiment. Okay, so whenever you toss a coin, you get some outcome, right? That is nothing but an outcome. Whatever the results you see, head or tail, that is nothing but an outcome of your random experiment. You get my point? Sir, what about event? Event means what is the probability that I can get a head? Getting head is one event, or getting a tail is one event. For example, I'm tossing a coin 2 times. Okay, then probability of getting 2 hits. First one head, second coin is also head. Here, what I'm measuring, I'm trying to find the probability of a particular event. What is the event? Getting 2 hits, getting at least 1 hit, getting 0 hits. These are nothing but events. Is this clear? Again, we have a definition. Again, I'll explain in depth. Okay, so simple. The probability is used to quantify the uncertainty. It will assign the probability to each possible outcome of a random event from a random experiment. Clear? See, the probability of an event E is a number that lies between 0 to 1. See guys, whenever you people calculate the probability value always lies between 0 and 1. 0 and 1. If your probability value is greater than 1, less than 0, means you did something wrong in your calculations. That's not the actual probability. What do you mean by 0 to 1? For example, if you're tossing a coin, the probability of getting an event called head, is equals to 0.5. 0.5 can be converted into percentage, means 5% or 50%. 50% is on a 0.5 into 100. 50% means there is a 50% chance that you might get a head. You get my point? So if you're getting probability is equals to 0.8, means there is 80% chance that an event can come or an event can occur. You get my point? So 0 to 1. 1 means 100%. 0 means 0% chance that you're going to get an output or you're going to get that particular event. You get my point? So that's how you calculate. So what is the formula to calculate the probability? See guys, in probability there are multiple types. This is known as a classical probability. Classical means very, very basic probability. So how do you calculate the probability is number of favorable outcomes divided by total number of possible outcomes. Whenever you conduct a random experiment, an experiment can give n number of outputs. So probability of an event E is equals to number of favorable cases divided by total number of possible outcomes. This is the formula that we are going to use. We calculate the examples as well. You see, okay? Now, so before going to do the calculations, here are the two important key points that everybody should remember when calculating the probability. Means, first point, the probability of any event should lie between 0 to 1. If you're tossing a coin, there are two possible outcomes. One is head, one is tail. If you're calculating the probability of head, it should be 0 to 1. If you're calculating probability of tail, it should be between 0 to 1. It should not more than that. This is the first probability. Next, the sum of the probabilities of all the possible outcomes of a random experiment should be equals to 1. Which means, for example, you are doing an experiment, a random experiment. There is 6 possible outcomes of a random experiment. So you have calculated the probability of each and every outcome, called each and every event. Everything is in between 0 to 1. Whenever you sum these 6 probabilities, P1, P2, P3, P4, and P6, everything should be equals to 1. If any one of these property is not satisfied, then your probability calculations are not enough. You need to change the formula, you need to cross-check the calculations. You get my point? So like that, you go and calculate. For example, let's see. Let's assume, guys, I'm tossing a coin one time. I'm tossing a coin once. Okay. So whenever you people are calculating the probabilities, you need to frame, before even implementing this particular formula, you need to take care of two important things. That is sample space and event. Sample space and event. Okay. So what is the sample space? Sample space is a mathematical set which consists of all the possible outcomes of a random experiment. You get my point? If I'm tossing a coin one time, then what are the possible outcomes? Head or tail. So whenever I'm tossing coin once, what is my sample space? Sample space, I said set, mathematical set will be represented with a curly braces. I can get a head or I can get a tail. So this is my possible sample space, right? Yes or no? So now I wanted to calculate what is the probability of getting a head. Here, what is my event? Event is nothing but getting a head. Getting head is my event. So how can I calculate this? As I mentioned, number of favorable outcomes divided by total number of outcomes. Now you see, by looking at the sample space, you tell me how many number of favorable cases that we have for head. 1. So is equals to 1 divided by total number of possible outcomes, 2. So what is the probability? 0.5. Same way, I wanted to calculate what is the probability of getting a tail. So you tell me how many number of positive favorable cases that you have? 1 divided by total number of cases, 2. So 0.5. You cross check, as I mentioned, whenever you do the random experiment, the probability of each and every possible outcome should lie between 0 to 1. 0.5 satisfied, 0.5 satisfied. Next, I said all the probabilities of all the possible outcomes should be equals to 1. So whenever you sum 0.5 and 0.5, you see some value. You see some value 1. Yes or no? Two conditions are satisfied. So your probability is properly calculated. Means whenever you toss a coin, there is a 50% chance you get a head, 50% chance you get a tail. Is it clear? Let me extend the same example by tossing the coin 2 times. Tossing the coin 2 times. Let's say I'm tossing a coin 2 times. Okay. So whenever you do conduct a random experiment, first and primary step is to create a sample space. So what is my sample space out of it? Either I can get to 2 heads, first coin head, second coin head, or 2 tails, or first coin head, second coin tail, or first coin tail, second coin head. These are the possible, no other possibilities. Okay. Now let me go and calculate the probability of each possible event. You get my point? Each possible event. So what is my first event? The probability of event called 2 heads. What is the probability of getting 2 heads? What is this? 1 divided by 1 divided by 4. 0.25. 0.25. Okay. Next, what is the probability of getting even 2 tails? Is equals to how many number of possible cases? 1 divided by 4. 1 divided by 4. I get my point. Next, what is the probability of getting first one head, next one tail? So how many possible cases that you have? 1 divided by 4. Same way, then what is the probability of getting first one tail and second one head? That is 1 divided by 4. 1 divided by 4. I get my point. Or else the same thing can also be calculated like what is the probability of getting one head and one tail. I'm not talking about first one head or first one tail. I'm talking about whenever I toss 2 coins, one will be head, one will be tail. In this case, you tell me number of favorable cases? 2. 2 divided by 4. 0.5. If you are hiding this, you tell me each and every possible outcome is in between 0 to 1. Sum of the probability is equals to 1. You see the below one. In Excel, whenever you select a rows, by default, it will give you 3 summary shortcuts. See, some value 1. Either this way you can calculate or even this also. What is the total probability? 1. Okay, depending upon the question, you can calculate the probabilities. So I just wanted to let you know how can you identify the favorable outcomes and the total outcomes. Are you getting my point? So this is how you calculate. Okay, so let me go by one more example. For example, I'm throwing a die. You know the dice, you have a 6 faces per particular die. So let's say I'm throwing a dice. So you people tell me what are the possible outcomes. Your voice is not audible. What about now, guys? People in online? Yeah, good. So let me say I'm throwing a die. Throwing a dice, you people tell me what are the possible outcomes in a sample space. So what are those? 1, 2, 3, 4, 5, 6. Yes or no? Either I might get 1, 2, 3, 4 or 5, 6. Yes or no? Now you tell me what is the probability of getting a number 1 as a outcome. Number 1 as a outcome. So what is this? Number of favorable cases divided by total number of cases. 1 divided by 6. Who is that last fellow? Are you listening or? No, that's what. So 1 divided by 6. Okay. Next, what is the probability of getting 2 as outcome? Same number of favorable cases is 1 divided by 2. Like that, if I go and calculate probability of 3 and probability of 4 and probability of 5 and probability of 6. Same way, same calculations will be done. See, is equals to 1 divided by 6. Same calculations comes from the remaining. Now you do cross check each and every outcome or probability of each and every possible outcome should lies between 0 to 1. Yes or no? And sum of the probability should be equals to 1. You select all. What is the sum value? 1. Is it done? So this is how you are going to calculate the probabilities. Clear? It's a basic examples to understand the concepts. Once we understand the concept, we'll go and see the customer churn problem. Usually the data science people will do the project. Okay. As I mentioned, sample space and event. Sample space is a set of, you guys, I already mentioned even example as well. The sample space is a set of all possible outcomes of a random experiment. I already explained you what is random experiment. You people should definitely know the basic definitions, guys. Okay. So, for example, while flipping a coin, the sample space contains heads or tails. Okay. Whatever the experiment you conduct, what are the possible outcomes? Those are known as a sample space. Clear? Then what about the event? See, an event is a subset of a sample space. You see here, I'm calculating the probability of an event called head. It is available in the sample space. Here, I'm calculating the probability of getting a number 4. The 4 event is a subset of sample space. Clear? Simply, you can say one line definition. Event is a subset of sample space. That is enough. Clear? So that's what. See, for example, in case of a rolling a die, I wanted to calculate a probability of an event that could be the outcome rolling a even number. See, I wanted to find the probability of getting an even number. You tell me here. Then what is the probability of getting even number? So here, I'm calculating the probability for an event called getting even number. So you tell me how many number of favorable cases you have? 3. What are those? 2, 4, 6. So number of favorable cases divided by total number of cases. There is a 50% chance whenever you're throwing a die to get a even number. You get my point? So this is how you calculate. Is it clear? So that's what. The key points to remember is, that's why I already mentioned, the total number of possible events in the is the number of subset of the sample space. Means whatever the possible outcomes you have, those are the numbers or members of sample space. Okay. And the probability of an event is the sum of the probabilities of outcome within an event. Okay. Say simple as two properties. Individual probability should lie between 0 to 1. Overall probability, sum of probability should be equals to 1. Clear? So that's what. And what are the types of probabilities that we have? Okay, we'll see. The first one is classical probability. We already have seen. We have multiple ways. We should know in which scenario we use which probability. Okay, first we'll go by classical probability. See, classical probability definition based on the assumption that all the outcomes in the sample space are equally likely. Means whenever you're conducting a random experiment, you know some outcome will come. Okay, let's say I'm tossing a coin or I'm throwing a die. You know, either you get 1, 2, 3, 4, 5, 6, but you're not sure what will be the outcome. So it is a random experiment. Yes or no? And here, whenever the each and every possible outcome has a equal chance of getting as an outcome, then you go by using a classical probability. Whenever you're conducting a random experiment, the outcome of that particular experiment, each and every outcome of a random experiment have an equal chance of getting selected, equal chance of getting as an outcome. Then in that case, if you wanted to calculate the probability, then we go by using classical probability. Clear? It's a primary assumption. That's what. See, same formula we have already seen. Number of favorable outcomes divided by total possible outcomes. Same example, tossing a coin. Okay, tossing a coin we have already seen. Next, what about empirical probability? Empirical probability is also known as a experimental probability. Okay, my point. Empirical probability is also known as experimental probability. Means you do some experiment, you get some outcome of an experiment. Depending upon that, you find the probability. You tell me, guys. Okay, even before this, I'll ask you one question. I have a coin. Slowly I'm tossing upside, I got head. Okay, roughly I'm tossing the coin or I'm throwing a coin to the wall. Still I got a head. Randomly I throw the coin into the water bucket. Still I got a head. You get my point? Slowly I flip to my coin. Still I got a head. However, the way you do, still you are getting a head. So what do you think? In the fifth attempt, you'll get definitely head. How? Because you are observing. Whenever you do the random experiment, continuously you're getting the same outcome. You're observing that. From the observation, the probability might increase. In the fifth time, for example, fifth time you wanted to bet some amount. So you bet on tail or head. Obviously head. Why? Because from the continuous experiment, you have seen that. Anyway, you're going to head. You might think the coin might be biased. So you directly put all your prize money into the head. Yes or no? The probabilities are changing or not depending upon the observation. That will be calculated by using the empirical or experimental probability. You get my point? Let's see. Empirical probability. Definition is that based on the observations or the historical data from the experiment or real world occurrences. Whenever you wanted to calculate the probability of an event based on the observations or historical data from the experiments or real world outcomes, in that case, we can go by using empirical probability. Okay. See guys, whenever you see the rain, you see the weather. Depending upon the weather, immediately you get the probability of getting a rain more and probability of getting a rain will decrease. Yes or no? If you go outside, it is sunny, then the probability of getting rain will decrease. Okay, if it is cloudy, then you will get a probability of getting a rain very high. So the probability increasing and decreasing based on the observation. So in such case, we can go by using empirical probability. So what is the formula to calculate the empirical probability of an event? Is number of times an event occurs and the total number of trials. How many times you have experimented? Out of that, how many times you got an appropriate outcome that you are expecting? Okay, I'll give you one example. For example, you people are observing 100 rainy days. In general, rainy season will be around 3 months. Yes or no? 3 months or 4 months. Let's say 100 days. We are continuously observing 100 days, whether it is raining or not. So whenever you do the observation, it rained around 60 days. Whenever you're observing 100 days, you'll able to see the rain 60 days. So then, what is the probability of getting a morning rain? You just observed every day morning 100 days, whether it is raining or not. You could see 100 days, it started raining in the morning. Then what is the probability of getting a morning rain? Is equals to first denominator and numerator. Denominator is what? Number of trials. How many days you have observed? 100 days. Out of 100 days, how many days it rained? 60 days. So number of times event occurred divided by total number of trials. 60 divided by 100. 60 divided by 100. So what is this? 0.6. So probability is lying between 0 to 1. And there is a 60% chance that you get a rain in the morning. You getting my point? See, even though you people observe, guys, mostly rain comes in the night or in the morning. In between midnight, middle like 1 p.m., 2 p.m., you don't see much of raining. Yes or no? Early morning or night when you are sleeping. Yes or no? So that is a proved probability. Clear? When the outcomes are random and each and every outcome have an equal chance, then you can go by using classical probability. If you want to find the probability by observation, then you can go by using empirical or classical probability. Is this clear? Clear? So that's what. Okay. Next. In the probability, there are two important rules, guys. One is addition rule of probability and another one is multiplication rule of probability. These are already stated and proved. We don't need to state and we don't need to prove like theoretical concepts we do in exams. Here, understand the objectivity. Addition rule of probability means here we make the use of union. In general mathematics, union means combination. If you say A union B, all the elements in A and all the elements in B will be combined as a new set. But in probability, union stands for R. Union stands for R. As of now, we have seen what is the probability of getting head, what is the probability of getting tail, what is the probability of getting 2, what is the probability of getting 5. If I'm asking what is the probability of getting 2 or 5, I get my point. I'm asking the question, what is the probability of getting either 2 or 5? If event A is 2, event B is 5, then what is the probability of A union B? What is the probability of A union B? How can we calculate? To calculate such events, we have already have a stated and proved formula that is called addition rule of probability. Is this clear? Why we are learning and why should I calculate these things? Okay. See, addition rule of probability. This rule will change depending upon the type of events. Depending upon the type of events. Events are basically two types. One is mutually exclusive and non-mutually exclusive. You get my point? Mutually exclusive, non-mutually exclusive. First of all, mutually exclusive. Try to understand. What do you mean by mutually? Coordination with one another. You have a mutual consultation. You have a mutual understanding. Means whatever the opponent will do, okay for you. Whatever you do, that is okay for your opponent. Yes or no? Excluding means eliminating. Eliminating. Yes or no? So whenever you say the events are mutually exclusive, in the sense happening of one event, occurring of one event excludes the occurrence of another event. Get my point? Occurrence of one event excludes the occurrence of another event. Then this is known as a mutually exclusive events. For example, I'm tossing a coin. If I'm getting a head means it stopped coming a tail. So that's why it came. Yes or no? So whenever the events are said mutually exclusive, as I mentioned, occurrence of one event will exclude the occurrence of another event. You get my point? Or you simply say that no two events can come together as one. You cannot see two outcomes at the same time. So that is nothing but mutually exclusive. You get my point? So if two events cannot occur at the same time, then they are known as a mutually exclusive. Then what is the rule? In that case, the probability of getting A or B, that is probability of A union B, is equals to probability of A plus probability of B. Probability of A plus probability of B. Is it clear? Okay. Now let's see the example. For example, I'm rolling a dice. What is the probability of getting a coin 2 or 5? Let's see here. So we are talking about addition rule, right? Addition rule. So what is this addition rule? Say that probability of A or probability of B, which is equals to probability of A plus probability of B. Yes or no? So now I'm giving an example. Throwing a dice. So what is the sample space, guys? 1, 2, 3, 4, 5, and 6. So this is the thing I have. So now I wanted to find the probability of, what is the probability of getting 2 or 5 as outcome. You get my point? I wanted to check what is the probability of getting 2 or 5 as outcome. How can I calculate? I'm talking about probability of 2 or 5. First of all, is 2 and 5 are mutually exclusive or not? Yes. If it's 2 coming, it cannot come 5. If it is 5 coming, it cannot be a 2. So you can go by using probability of A into probability of B. So which is nothing but probability of 2 plus probability of 5. So which is nothing but probability of 2. How much? 1 by 6 is nothing but, okay, I'll go by this, is equals to 1 divided by 6 plus, what is the probability of getting 5? Same, 1 divided by 6. So what is the probability? 33%. There is a 33% chance you might get a 2 or 5. Same way you can go by calculating 4 or 5. Okay, like that. 4 or 5 or 6. Probability of A plus probability of B plus probability of C. Like that you can extend the formula. You get my point? So this is what addition rule of probability is talking about. This is what addition rule of probability is talking about. Is this clear? Okay, now let's go to this. Then what about non-mutually exclusive? Non-mutually exclusive means happening of one event is not excluding the happening of another event. Happening of one event is not avoiding the happening of another event. Okay, in that case, you can go by using this as a non-mutually exclusive. For example, you are not coming to the college regularly, obviously you get failed. Yes or no? Is if you're coming or not coming to the college, is it excluding whether you're going to get a pass or not? No. Yes or no? It is including. If you're not coming, it will include that you're going to fail. Yes or no? In such case, we can go by using the formula called probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. In regular days, whenever you people work with the data, you will never ever see non-mutually exclusive events. You always go by using the data which is mutually exclusive only. You get my point? If that is the scenario, we have a lot of things to discuss. If you have such a kind of thing, I'll get an example. I'll explain you that way also. But I mean, let it be. You clear? So when the events are non-mutually exclusive, then the probability of A or B is equals to probability of A plus probability of B minus probability of A intersection B. Sir, I know what is probability of A union B. Probability of A, probability of B. What is this probability of A intersection B? I said in probability union stands for or, intersection stands for and. What is the probability of getting event A and B together? A and B together. Are you getting my point? A and B together. In that case, we can go by calculating the probability of A intersection B. A intersection B. So, see, before going to understand what is the probability of A intersection B, that is known as a multiplication rule of probability. Probability of A union B is known as addition rule of probability. Probability of A intersection B is known as multiplication rule of probability. How you have some conditions for addition rule, like mutually exclusive, non-mutually exclusive. Same way, to calculate the multiplication rule, you should know a few more types of events. What are those? See, mutually exclusive, independent, dependent. Independent rule, you should have some conditions. A union B before going to A intersection. Are you getting my point? A and B together. In that case, we can go by calculating the probability of A intersection B. A intersection B. So, see, before going to understand what is the probability of A intersection B, that is known as a multiplication rule of probability. Probability of A union B is known as addition rule of probability. Probability of A intersection B is known as multiplication rule of probability. how you have some conditions for addition rule, like mutually exclusive, non-mutually exclusive. Same way, to calculate the multiplication rule, you should know a few more types of events. What are those? See, mutually exclusive, independent, dependent. Independent and dependent. We'll see. I already explained you what is mutually exclusive. Same thing I mentioned here as an example. Same thing I mentioned here as an example. You get my point? So, two or more events are mutually exclusive if they cannot occur at the same place. Yes or no? So, this is how you're going to calculate. And exhaustive events. What do you mean by exhaustive? Exclusive is different. So, this is how you're going to calculate. And exhaustive events. What do you mean by exhaustive? Exclusive is different, exhaustive is different. So when you say the events are exhaustive events, means a set of events is exhaustive if it is including all the possible outcomes of a random experiment. Which means whenever you conduct an experiment, you have a sample space. Each and every item or each and every element in the sample space have a chance to get as an outcome. Then the events are known as exhaustive events. Means whenever you do random experiment, all the possible outcomes, right? There is must one output will come. Definitely one outcome will be sample space only. You get nothing out of this particular sample space. Then those events are known as exhaustive events. See, a sample space is completely covered by these events. All the values in the sample space are nothing but exhaustive. Every value in the sample space is known as an exhaustive event. You clear? So that's what. See, the multiplication rule of probability. Here, you need to take care of independent and dependent. Independent and dependent. Okay, independent events and dependent events. I'll give you one thing. Let me go here. For example, I have a bag. A bag contains 3 different colors of balls. Let's say bag of 3 balls. I have a bag of 3 balls. So one is red color ball, one is white color ball, one is blue color ball. Okay. So what I'm doing is I'm randomly picking up one particular ball. I'm randomly picking up one particular ball. You get my point? I'm randomly picking up the ball. I'm watching what is the color of that ball. Again, I'm replacing the ball in the same bag. Sampling with replacement, we say this as. I'm collecting a sample out of the bag with a blindfolded. I'm picking up the ball. I'm seeing what is the color it is. I'm identifying and I'm replacing the same ball again into the bag. Now you tell me, in that case, what is the probability of getting a red color ball? What is the probability of getting red color ball is equals to of getting a white color ball. See, I'm taking and I'm replacing. Yes. No. See what I'm saying? I have only 3 balls. If I pick and replace, I'll get only 3 balls only. Right? I'm not getting another ball. See, I have 3 balls. I took a red color ball. I see and again I'm replacing. Still 3 balls only, 3 colors only. You get my point? Same ball. I replaced. So still I have 3 balls. So divided by 3. You see, individual probability lies between 0 to 1 and total probability equals to 1. Clear? So this is the example for randomly is nothing but an example for conducting. But here randomly selecting one ball without replacement with this red color. First of all, I said is equals and I'm not probable cases 1 and here going to be 1 white color probability of another event. For example, probability of one event is affecting the probability of another event. Then those events known as a dependent events. You clear when you say the dependent events and when you say the independent events? Is this clear? So people in online, is this clear, guys? This one back again. So before going to understand the multiplication rule, you should know what is dependent and what is independent. That's why I explained all those things. Clear? Now What is the multiplication rule of probability is talking about? First thing, if your events are independent, then if the occurrence of one event does not affect the occurrence of another event, then it is independent. In that case, what is the multiplication rule is saying that probability of getting A and B together is equals to probability of A multiplied by probability of B. I get my point? You get my point? See, probability of occurrence of A and probability of occurrence of B is equals to probability of A into probability of B. For example, tossing two coins. Then what is the probability of getting the first one as a hit? First one as a hit, 0.5. Second one is also hit, 0.5. See, first time I toss, either I get a hit, either I get a tail. What is the probability of getting hit? 0.5. Done. Again, I'm tossing the coin. Same. Probability of getting hit or tail. What is that? 0.5. So every time whenever I toss, you tell me, first time I got a hit, so that next time I'll get a tail. First time I tossed, I got hit. So obviously, automatically, the next time I'll get a tail. No. Happening of one event is not deciding the happening of another event. So independent, or even you say exclusive. Okay. So how do you calculate probability of first one hit and the second one hit? Or probability of both hits is equals to 0.5 into 0.5. That is nothing but 0.25. Even you see here, what is the probability of getting two hits? 0.25. 0.5 matching or not? So this is how the multiplication rule of probability is talking about. Don't worry, I have a separate example to get this thing again. Okay. So this is how you calculate the multiplication rule of probability. Clear? Let's say for dependent events, there are the events, those are dependent of each other. How can we calculate the probabilities out of it then? See, if the outcome of one event is affected by the outcome of others, then you say the events are dependent of each other. In that case, how can we calculate the probability of happening A and B together is equals to probability of A into probability of B by A. Probability of B by A. In the probabilical terminology, we have to pronounce this as probability of A given B. Sorry, probability of B. B given A. Probability of B by A is pronounced as probability of B given A, which means probability of A we already know. Then what is the probability of B after getting A? Are you getting my point? Probability of happening on event B when an event A is already happened. Are you getting my point? Here, what do you mean by probability of B by A means probability of getting event B when an event A is already occurred. Okay, so in that case, we can go by using this particular thing. Okay, you see this example, guys. For example, I have a bag of 3 red color balls and 2 blue color balls. One ball is drawn and not replaced. Then another ball is drawn. Okay. So what is the probability of getting the first ball as a red color? What is that? 1 divided by 5. Clear. Next. Then what is the probability of getting the second ball? What is the probability of getting the second ball? That is also red color when first ball is already a red color. First ball is red color. Then what is the probability of getting second ball is also a red color? That is probability of second red divided by first red. What is that? See, already you took one ball out of it. So total number of balls, how many? 4. Earlier you have 3 red color balls. So number of favorable red color balls, 3. But now you took one out of it. So number of favorable red color balls, 2. So 2 divided by 4. So to get the multiplication rule, you need probability of A, you need probability of B by A. You got the both. So then what is the probability of getting first red and second red? Probability of A and B. Probability of A and B. Then that is equals to probability of A into probability of B by A. So this is what. You clear? Understanding this example is very, very important. If you understand this only, next we are going to see about the conditional probability. Next we are going to see about the Bayes theorem. This is the basic. If you understand this, same will be replicated in conditional, same will be replicated in Bayes theorem. Are people getting my point? So that's why. I hope this example is very clear for you. Okay, even online people as well. Sir, why not probability of A plus probability of B? Because I'm not talking about either A or B. I'm talking about A and B. Okay, sir, why not means I don't know. The people tested and proved the statement. I'm using that. That's all. Okay. If you ask me, sir, why A plus B whole square is equal to A square plus B square plus 2AB, I don't know. Someone gave me that. I'm giving it to you. That's all. Clear? You cannot ask. You cannot judge the theoretical statements. Okay. So these are the summaries. Just a summary point. Whatever we have discussed as of now. See, classical probability. Favorable by total. Example, coin toss. Empirical probability. Observed frequency divided by total trials. So rainy days is example. And addition rule of probability. When the mutually exclusive, then probability of A union B is equals to probability of A plus probability of B. Example, rolling a die, getting 2 or 5 out of it. Addition rule for non-mutually exclusive. What is the probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. Multiplication rule for independent, probability of A into probability of B. Multiplication rule for dependent, probability of A into probability of B by A. It's a typo mistake, okay? It's a typing mistake, sorry. Okay, so this is the summary. Is this clear? Now we see about the conditional probability. Then immediately we go to the customer churn problem. I created one more PDF. Let me explain you how we are calculating, how important it is being a data scientist to calculate the probabilities, and how we are going to give a business insight out of it. We'll see. Then we'll close it. Okay, so that's what. Conditional probability. In the name itself, you have depending upon one condition, you are going to find the probability. Depending upon one condition, you are going to get the probability. That is nothing but conditional probability. See, conditional probability is the probability of an event occurring given that another event has already occurred. You get my point? I wanted to calculate the probability of happening one event depending upon that, or given that an event is already has occurred. You get my point? I'll give you a regular example. Randomly, I'm calculating what is the probability of a customer going to buy a bread packet. You go to any DMart or you're going to any supermall. So I'm checking what is the probability that Rajendra Prasad is going to buy a bread packet. Random. Let's say I got 0.2, 20% chance. Or let's say 0.1, 10% chance only. Yes or no? Usually no one will buy the bread packet regularly until unless they have a kids. Yes or no? So 10%. That is normal one. Now I'll ask you, what is the probability of Rajendra Prasad is going to get a bread packet if he's already buying a milk packet? He already have a milk packet in his cart, the bag. Increase, right? The probability is increasing, yes or no? From 0.1, 10% to it might go around 50%. 50% chance, yes or no? If he's buying 10 rupees milk packet, okay. If he's buying liter milk packet, then the probability is increasing, yes or no? So probability of happening one event, given that an event is already has occurred. To find this, we go by using conditional probability. And same way, what is the probability of a person going to buy a bread packet is already buying a peanut butter? We know obviously, peanut butter you cannot consume directly. You definitely need a bread or chapati or something else to eat. So the probability immediately goes from 50% to 80%. Yes or no? See, depending upon the condition that one event is already happened, then what is the probability of another event? You get my point? If he's coming regularly to the college, then what is the probability of he's going to get a first division? He's answering each and every question asked by the faculty, then what is the probability he's going to be a successful in a career? Are you getting my point? So such kind of things can be calculated by using the probability called conditional probability. I hope this is very clear how we are calculating and why we are calculating. That's what. The formula for calculating the conditional probability into the dependent rate. For the probability is increasing, yes or no? So probability of happening one event, given that an event is already has occurred. To find this, we go by using conditional probability. And same way, what is the probability of a person going to buy a bread packet is already buying a peanut butter? We know obviously, peanut butter you cannot consume directly. You definitely need a bread or chapati or something else to eat. So the probability immediately goes from 50% to 80%. Yes or no? See, depending upon the condition that one event is already happened, then what is the probability of another event? You getting my point? If he's coming regularly to the college, then what is the probability of he's going to get a first division? He's answering each and every question asked by the faculty, then what is the probability he's going to be a successful in a career? Are you getting my point? So such kind of things can be calculated by using the probability called conditional probability. I hope this is very clear how we are calculating and why we are calculating. That's what. The formula for calculating the conditional probability is probability of A given that the B is already happened is equals to probability of A intersection B divided by probability of B. See, to remember the formula, what is the denominator? That will be the denominator. The numerator will be same, guys. Even if you calculate what is the probability of B, given that an event A is already occurred, means probability of B by A. What is the formula? Probability of A intersection B divided by probability of A. Probability of A. Is this clear? So that's what. Here, probability of A intersection B is the both events A and B occur together or occur at the same time. Then what is the probability of B? Probability of B is the happening of an event B. Means what is the probability of B? That is already happened. That is already calculated. Clear? So that's what. Okay. So this is about the conditional probability. So forget about this example. I have a very good example in the another document. Let me show you that. See, the basic and every company, every business will face the problem is customer churn. What do you mean by customer churn? What is a customer churn? Means you usually come to my shop, all of a sudden you're going to another shop. You converted from my business to another business. That is nothing but a churn. See, before Jio, we all used to work with Idea or Airtel. We don't know other than that. All of a sudden, everybody converted from Idea to Jio, Airtel to Jio. Yes or no? The customers of Idea converted to customer of Jio. That is nothing but churn. Every business faces this particular problem. So every business will struggle to decrease the customer churn rate. So being a data scientist, this is your regular problem. You need to decrease the customer churn rate, or you need to give a prediction whether a particular person is going to be a converted or not. A person is going to churn or not. Why should it is important? For example, I have a probability, or I know the chance that Rajendra Prasad is going to convert. That is 90% chance. So what can I do? So what can I do? I immediately offer. Immediately I'll offer. If you buy one thing, buy one get one. If you buy, you get a 50% discount. Then immediately I'll go and buy. So if I'm purchasing, means still I'm a customer of you. Yes or no? How do you identify whether a customer is converted from your business or not? You continuously observe 3 months. Is no order given by that particular person from the past 3 months, then it converted. Like company have a limitation. Depending upon that, you decide whether the customer is converted or not. How can I find? If I know in prior, if I'm able to predict in prior, the customer is going to convert it, then I can take an action plan. Yes or no? So how can I do? By using the probabilities. By using the probabilities. Let's see how can we predict what is the customer conversion rate by using the probabilities. Clear? See. Business problem, customer churn prediction. You are a data scientist in a telecom company. The management is asking you, why are my customers are leaving? And how can we predict who will churn? So we will use the same data set, whatever we are going to use for all the probability concepts that we have discussed as of now. Clear? First of all, given data. It's real as every day we see this. Okay. Last month we have observed one particular data. What is that? Last month, the total number of customers we have is 1,000 customers. Like say new orders or whatever it is. We have 1,000 customers from the last month data. Okay. In that, we have already observed 120 people are already converted. 120 people is already converted. We have observed, right? See, whenever you do the machine learning algorithms, you train the machine on the available data that is already happened. You give a output, you give a input. Yes or no? Whenever you train the machine learning algorithm, you give a target variable, you give an independent variable. Both will be given. Then only it will identify the predicts. What if X, then what is Y? If X is something, what is Y? Depending upon that, it will remember the patterns. Then when you give a new X, it will cross check, it will validate, and it will give you the predictions. Are you getting my point? Okay. So to do that, you give available and you give expected. See here, total number of 1,000. I have observed that out of 1,000, 120 people is already converted. And I have already seen out of 1,000, 200 people are already complained about something. Product is not good, quality is not good, price is very high. Like that, the people have complained.
you.